And the answer now is yes. So feel free to ask that question multiple times. Yeah. Yeah. Well, luckily the other part wasn't recorded. Somebody would think I was drinking before class. Although those little cups in the dining hall are like shot glasses now. Have you seen those? They're like this big. What is up with that? I know. They're tiny. So trig expressions have to do with the proportions of all these sides. And so it's helpful in more ways than you think. It helps you determine what one of the lengths of the triangle is if you only know one of them. It helps you find the angles. But let's get to our definitions. So you have sine.
Is this like the sohcahtoa stuff?
Yeah. Sohcahtoa is happening. Cosine. So these are their abbreviations. Sine is spelled S-I-N-E. Cosine is spelled like that, but we abbreviate it this way. This is a symbol that's generally used. It's the Greek letter theta. It's generally used as a variable when we're talking about angles. It doesn't matter what that is. I could use X to represent my angle. I could use A to represent my angle. You can use whatever variable you want. It's just most often that Greek letter theta is used. The biggest sin you can make in math is to write sine without an angle. And that's a sin.
I thought that's what you
Yeah.
So you knew it was funny ahead of time. That's why you weren't laughing, probably because
I laughed before you said it.
I know. It's like I gave it away. You cannot have this expression without an angle. It makes no sense. You can't say the sine. It's the sine of an angle. The sine tells you the ratio of the sides. So it can never exist by itself. Okay, it always has to have an angle attached to it, a symbol of an angle or of some variable. This can never exist on its own. All right, that's the ultimate no-no. So in other words, so I was just reminding you of the biggest sin you can do is you can't cancel those because sine cannot exist without an angle. Okay, so you would never do this. This is in case you're following along later.
Something I would do.
And then no, I mean always come back. Always come back so there's more learning to do. Always. Yeah. Always come back. So you have sine of an angle, cosine of an angle, and then you have something called the tangent of an angle. Tangent. We abbreviate as TAN. Those are the three main ones. Those are the primary ones. And then if you flip each one upside down, you get their invert. Well, not their inverses, their reciprocals. So sine's reciprocal is something called cosecant. Cosecant. Cosecant is that word. It's abbreviated CSC. The reciprocal of cosine is secant. It's abbreviated as SEC. And the reciprocal of tangent is cotangent. I knew that was coming.
How did you know that?
Well, because you say SEC and you're living in East Tennessee. Somebody's going to say it. No, I like the SEC. I prefer it. I think they're dominant. Yeah. So these are your 6 trig functions that you need to know. We're going to talk about their relationship with right triangles. What's cotangent is the last one. Did I write it? Oh, I had to write it up here because I ran out of room. So it's abbreviated cotangent.
But they never told me what it meant.
Really?
Yeah. It's weird, really.
Well,
I didn't know reciprocals.
maybe you were on your phone.
No, I wasn't.
Taylor, to be fair.
To be fair, I wasn't on my phone.
Okay.
No,
All right.
I wasn't paying attention.
So you've heard people talk about sohcahtoa, and this is what they're talking about. Remember the sine of an angle. It tells you about the relationship between two of those sides of your triangle. And it tells you that the sine of an angle is the relationship between the opposite side over the hypotenuse. Op over hip. So you might want to write what op stands for. It stands for opposite. HYP stands for hypotenuse. So we have a picture of a triangle there. I'm going to put my angle that I'm talking about right there. I know the measure of that angle in the corner. That's my right angle. That's 90 degrees. I don't necessarily know what these are. But this little angle that I'm calling theta, I can tell you about the relationship between some of the sides. And so when I say op, I'm talking about the side opposite the angle, which would be, right here. Okay, so here's my angle. This is opposite of it. So this would be what we're referring to as the opposite side. And hypotenuse is always the longest side of the triangle, so that would be when we're referring to this longest side of the triangle. Across from the 90 degrees, that's my hypotenuse. Okay. So, here's my triangle. Let's say I have a triangle that is, we'll use that same one since we already have that drawing. 3, 4. This one is a real triangle. That one is real. 9 plus 16 is 25. So, and I want the sine of theta. I would now fill in the numbers. The sine of this angle right here, this theta angle, is the opposite side, which is 3, over the hypotenuse, which is 5. So the sine of theta equals 3/5. If you know the sides of the triangle, you can figure out what the angles are by doing all this process in reverse. So that's the relationship of sine. Sine represents the opposite side divided by the hypotenuse. Cosine represents the adjacent side divided by the hypotenuse. So in that same 3, 4, 5 triangle, the side adjacent theta, adjacent meaning next to. So sometimes people say, well, there's 2 next to it. This side is next to it, and that side is next to it. How do I know which is the adjacent? Yeah, because 5 is the hypotenuse. It's already got a name. So 4 is the adjacent side. The hypotenuse is 5. So the cosine of theta would be 4/5. Let's see. Let's get rid of this fella.
So is hypotenuse height? Is that
Yeah, I think I hyped it. I'm not really sure what the E is doing there, but also the Y and P are sharing.
Yeah.
You know, that's just, cooperation between
keep it like that?
trig expressions. Tangent of our same 3, 4, 5 triangle. The tangent is the relationship of the opposite over the adjacent. Opposite side of my angle is 3. The adjacent is 4. So I don't use the hypotenuse in my tangent. So this says the tangent of the angle. So I go to my picture. Here's the angle. And so the side opposite that angle is 3. So I put a 3 next to the word opposite. The side adjacent, meaning next to it, is 4. And it's not 5 because 5 is the hypotenuse. So that's how I know it's 4. So tangent is 3/4. Tangent is also, by the way, this is another definition of tangent, not having to do with sides. Tangent is also the sine divided by the cosine. So if I did that, and I took my sine value of 3/5, and I divided it by my cosine value of 4/5.
Seems like a lot of work.
Yeah, I don't like that.
No.
I got you.
Wow. 3/5 divided by 4/5. Back in 3rd grade, somebody told you when you divide 2 fractions, you flip that second one upside down and multiply. Oops. As a times. Look at that time. That's inspirational, that times. 5s cancel and you get 3/4.
Why would you want to do that when you can just use that?
Well, the reason you want to do it is to prove that tangent is sine over cosine.
That's just way easier.
So 3/4 is opposite over adjacent, but there will be times where you do not have opposite over adjacent, but you do have the sine and cosine value. So you need to know that tangent is sine over cosine. When we go to unit circle, we don't have sides. We don't have opposites and adjacents. We do have sines and cosines. So you need to know that tangent is sine over cosine. And you'll be doing lots of fraction divisions. So when you are dividing 2 fractions, top one divided by bottom one, Whoa. Flip that second one upside down and multiply. And you'll have to do that a ton. Okay? Top one is 3/5. Divided by, flip that upside down, and multiply. The 5s cancel, and I got 3/4. Or eyeball it. Those 5s cancel, and you get 3/4. That's nice. I'd rather you eyeball it from here and say this denominator and this denominator are the same, therefore they will cancel. That's handy. So cosine, sine, and tangent are your 3 core. And the other 3 are reciprocals.